Hi everyone, welcome to today's webinar, The Critical Role of Spectrophotometer Maintenance, Ensuring Color Accuracy. Presenting today is Tim Mao, the Global Customer Solutions Manager at X-Rite. I'm Robert Grotans, the Global Experience Manager, and I'll be moderating today's webinar. I just want to go over a couple of things before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. If you have any questions during today's presentation, please use the questions function on the GoToWebinar panel, and we will have some time at the very end of this webinar to answer a few of those questions. Finally, this webinar will be recorded, and we will follow up with an email after this webinar with a link to the recording so that you can watch it again. So with that, I will turn it over to Tim to get things started.
Thank you, Robert. Welcome, everyone. Let's dive into our topic today, talking about spectrophotometer maintenance and ensuring color accuracy, and making sure that you have faith and trust in what you're getting as results. So, advance that to the next slide. So, our agenda for today is this. First, we're going to talk a little bit about color accuracy. And what kind of things get in the way of producing color accurately, and how can the instrument have an impact on that consistency? And then secondly, we'll talk about actually maintaining your spectrophotometer, and we're going to address these topics of calibration and cleaning, something called net profiler, and certification. So let's start talking about the color accuracy. What kind of things get in the way? So when we're talking about color accuracy, what in my mind, what I'm thinking really is I'm trying to produce something, and I'm trying to produce it the same color today that I did yesterday, that I did a month, a week, a year ago, right? I'm trying to meet that color standard. I'm trying to be accurate in doing that. There are things that get in the way, and they can include things like production variables, something you're all probably very familiar with, right? The way a piece of equipment in production is functioning, the speed at which it's running, those kinds of things in production can introduce variability in the color you produce. So can raw materials, obviously, right? You buy the same colored pigment from the same supplier, but their production has variables in it. That means that your raw material has variables in it. And so that can lead to reducing some of the accuracy you have in reproducing color. Environmental variables, the same production done in the summer and in the winter, depending upon where you are located, can be very different because the temperature and the humidity may have changed. That can cause things to be produced differently and have different color. There are operator variables, whether it's a skill difference in operators, or just not even necessarily a skill difference, but just people do things slightly differently. As much as we might have SOPs and everything to kind of control that, operators can contribute to color variation as well. And the instrument itself can contribute to it. And what we're going to talk about for the majority of this webinar is about how we can control those variables that the instrument might be introducing into our process. And of course, there are many more things, and all together they create what we call an error stack. So this is not a specific error stack, but each of those pieces of that stack might represent one or more different variables, and add them up and you can end up with a fairly large delta E. So what you want to do is control those variables, and we want to make sure we can control the instrument's contribution to those variables as much as possible. So let's dive into how we're going to deal with that, okay? We're going to deal with it by looking at the variables that can come from an instrument. For example, its calibration state may contribute to that. Its cleanliness, right? Is the instrument gotten dirty? Is there dust inside of it? Has it been handled properly? If I have a portable instrument, is it being kept clean? Was it being handled correctly? Was it dropped? Something like that could have an impact on it. I may have environmental impacts as well, because temperature and humidity not only can affect the color of your whatever product it is you're producing, but they can have impact on how a device is working and how well it measures color. And the issue with all of those is that if those things are going on, they can create a false color problem. So imagine, back to that error stack, if the instrument's contributing too much difference because the instrument is not measuring like it did or like it should, you might have added a couple of points to your delta E and gone from what was okay to not okay, right? And so they can create that false color problem. So how do we try and address that? Well, the goal is to try to maintain something called IIA, or inter-instrument agreement. All instruments that are produced by X-Rite, even other manufacturers, will have a specification for inter-instrument agreement. What that means is if I buy two of the same device, natively, how far apart can I expect them to measure from each other? Because of course, producing instruments, you can't produce every instrument to be identical either, right? There's production variables and things that go into that, electronics, so on. So there is always some inherent difference between devices. They tend to be fairly small, but if that gets out of control by these other variables, then it starts to cause a problem. And it's important to maintain that inter-instrument agreement, especially if you have a fleet of devices. Maybe you have the same device in multiple locations in a single plant, across multiple plants, across the globe, whatever, and you're going to communicate color to each other. You need to be able to have faith that those instruments are maintaining that inter-instrument agreement, so you know that they're reading color the same. It could also be across a supply chain. So maybe it's not just within your own company, but it's a supplier or a customer, right? Who's also measuring the same thing you are. You want to make sure that that's being maintained. And then we talk about those quite often when we talk about inter-instrument agreement, about fleets of devices and supply chains. But maybe this one's the most important. And that is maintaining inter-instrument agreement to itself. So assume you only have one device, and maybe you thought those previous two bullets didn't really apply to you, right? You've got a single device, but if you use that device when it was brand new 5 years ago to measure a color standard, and now you're measuring samples against that color standard today, 5 years later, if there's been variables in the instrument that have caused it to move over 5 years, you're now comparing back. Yes, you're comparing it to itself, but the device has changed. And so that inter-instrument agreement over time is maybe the most critical one, but they are all very important. So how do we go and deal with those? Well, number one is calibration. It's pretty standard and straightforward. The devices and software will force you to do this. Typically, they're with white and black, right? If you have a benchtop, the pictures on the top will look familiar. If you have a handheld, the pictures on the bottom might look familiar, right? So you're measuring a white, you're measuring a black, and what does that do? Well, it does two things: confirms and adjusts. It confirms that your instrument is still maintaining and living within its reflectivity limits. White being the most reflective thing, black or a light trap is really what those black things are, right? As zero, so I know what 0 and 100 are, and then I can calibrate and function within them. And it also adjusts, right? There may be some minor contamination. A lamp, as it ages, emits light slightly differently, and so it's adjusting for those things. That's what your daily calibration is. Some instruments don't require it daily. Some instruments, you might be doing it every 4 hours, right? A lot of it depends on the device and the use case. But that calibration is making sure, yep, it's still measuring in that same range of reflectivity correctly. Then we've got to talk about cleaning. It's recommended to be weekly, but the frequency is really environment dependent. So you may be in a extremely dusty environment where you clean the device at the beginning of every shift. You may be in an extremely clean, clean room kind of situation where you can clean the device once a month and it won't be a problem. Okay, but whether it's daily, weekly, monthly, or whatever, it's really important to follow the instructions in the manual. For example, for a handheld CI6X device, that's a screenshot from our manual that shows the proper way to do it. We have the same thing for benchtops. So we tell you how to properly clean it. Mostly it's to keep dust and things out of the optics and out of impacting your measurement. It's also important that every time you clean it, you then recalibrate, because of course, if you calibrate and then clean, you've just changed it after you calibrated, and now you need to calibrate to realign things. And then for some extreme conditions, we actually have, for the benchtop device, a dust filter kit. And yes, that white is literally a filter. And so electronics, we all know that from looking at our computer monitors or our television sets or whatever, are magnets for dust, right? They create the electricity inside of them, turns them into electromagnets essentially, and dust just adheres to that. So if you're in a fairly dusty environment, it may mean that you need to be able to protect that device by putting that filter kit on there and stopping the dust from getting inside the instrument to begin with. Okay, so cleaning is very important. All right, so we did daily, weekly, now we're up to monthly. And in monthly, the solution here is Net Profiler. This is a very important step that is an X-Rite unique solution. And what Net Profiler does is this: it's a piece of software that walks the user through a process. The software looks like that, just a screen grab to show you kind of what it does. It uses some tiles that are serialized with data in the cloud, and the tile set looks a bit like that. Those tiles are about 2 inches, 2-inch square tiles. And then the process is this. So through the software, you measure those serialized tiles. That data is compared to the cloud data. And the cloud data for those tiles is that those tiles, before they were sent to you, they were measured with an X-Rite centroid device. So our center point, centroid, that's what a centroid device is. It's an instrument that is the standard by which all other instruments are compared to. So it's what it's supposed to be in a perfect world. So that centroid device has measured those Net Profiler tiles, right? And the data is stored in the cloud. Now you measure with yours, and we get a calculated value. You can see up here, this one says unprofiled, it was 0.250 delta E. So that's how far off that instrument compared to the centroid measurement on those tiles. But you'll see underneath there, it says new profile generated 0.06, okay? And so a profile is created if it's necessary, if it's needed, and downloaded into the device. So that profile is going to adjust for how that instrument measured differently across all of these different colored tiles. There's whites and grays and some chromatic tiles and so forth. And then that profile, once loaded into the instrument, every measurement taken thereafter is identified as measured with this active profile. And so it's like every month bringing your device back to the centroid, getting it as close to the centroid as we can. And that work that's done every 30 days, you profile again. Sometimes it reuses the existing profile. Sometimes it generates a new profile. Okay. And then at the end of that, you get a certificate of the Net Profiler results. The certificate's for a different device. And you can see it actually tells you in this table, how far off was it unprofiled on these various color tiles, and where did I go after I applied the profile. So you end up measuring the tiles twice. Once you measure them and it calculates the difference you have, and then it measures them again after it applies this new profile to validate, yes, I improved it in this case from 0.16 to 0.06 delta E. So I've just saved myself in this example essentially 0.1 delta E of error that my instrument would have produced had I not profiled it. And that 0.1 delta E, again, depending on what your tolerance is, can mean the difference between pass and fail, right? It can mean the difference between you going out and troubleshooting a color problem that might actually have been not had to been troubleshot because the instrument contributed a little too much to it. All right, to give you an idea of the kinds of results we might see, these are some averages from a large, I think it was nearly 300 different devices that we looked at and averaged the results together. So the size of those red shapes, I guess, I don't know what else to call them, right? That's how far off in delta E those instruments were on each of those varying tiles. The green is after a profile was applied to those instruments. So all the space between the red and the green that you can see, all of this area is error that's been corrected by Net Profiler. So it's brought, you can think of it like this, it's brought these instruments from having this kind of cloud of agreement with the centroid, which would be in the dead center, to that kind. So we've reduced that much error, right? And one of the things that's really key is Net Profiler is not only is it correcting this because of drift and dirtiness and things that might be going on with your instrument, but maybe most importantly, it's doing it, as it says here, in your environment. Because when we produce an instrument and test it for inter-instrument agreement and all those kinds of things, our production facilities in an extremely tightly controlled environment. It's 72 degrees plus or minus 1 degree in there, right? The humidity is controlled very tightly. So it's a really tightly controlled environment. You live in an environment where you live, right? I mean, or work. That's what you work in. That's where the instrument is being used. And so if you net profile the device in that same environment, it's some of what this is correcting for is the fact that your environment is different. But again, all of those work together to bring that instrument back to the centroid so that month after month, as you profile, you can validate and know that your instrument's still measuring the way it measured when you started with it, when it was brand new instrument. Now, there is another step beyond that, and then now we're at an annual basis. We went from daily to month or weekly to monthly, now to annual, and that is certification. So what is certification? It's kind of like Net Profiler, except that it's a validation that a native device meets the specifications versus the centroid. So typically this is happening when you send your instrument to X-Rite, right? Goes into our service center and we're putting it into this tightly controlled environment. Now we're going to test it and see natively, if I just measure similar to those tiles, if I just measure, does it pass the specification? It's done by X-Rite technicians, or we have some certified partners that can do it. We're using NIST traceable media, so that's what the colors standards that we're using are traceable back to NIST. It can even include ISO 17025, sometimes called A2LA certification. That's dependent on the different types of devices. We can do that for many of our devices. Some don't qualify. But what we're doing is making sure that your instrument natively measures the way it's supposed to measure. Okay? And if that device it fails to pass certification, then we need to adjust it, or potentially, if adjustment won't get it there, we may have to repair something so that that device will meet the specification. So if you've been doing your net profiling on a monthly basis, and Net Profiler is correcting errors, right? It might be correcting errors that are due to the environment. It might be correcting errors or differences that are due to wear and tear and cleanliness and all that kind of stuff of the device. When we come to certification, we're eliminating the environment change because we're putting it in our environment. And we are then testing the device so that we can natively correct any errors so that you don't have to correct those in NetProfiler going forward. Okay, so that's validating and certifying that the device is working as it was designed and intended to work. So maintaining your spectrophotometer is really about keeping your instrument calibrated, clean, net profiled, and certified. And that ensures that your color measurements are consistent, accurate, and precise, right? And hopefully it allows you to focus then on the root cause of any real color variation. So if you know your instrument is, you're maintaining it properly, you're doing all of these things, right? You can have great confidence and faith in your device. Your device is doing it right. So if your device is reporting a color difference, it's real. It's not something that might be being contributed to by the instrument having drifted, so to speak, right? So it allows you to focus on the real color variation problems that may exist. All right, with that, we have reached time for us to do a bit of Q&A. So I'm going to turn it back over to Robert, who is going to moderate this part for us.
Thank you, Tim. If you have any questions you haven't submitted yet, please feel free to do so now. While we wait for questions to come in, I am going to pop up a polling question. If you are interested in talking to someone or reaching out and learning more, feel free to answer this, and we'll see if any questions come in while this is up on the screen here. So I see our first question here. Is it helpful to think of NetProfiler as, or NetProfile as a mini annual recertification done on site?
Yes, in fact, that's a way it's used by many people. It obviously isn't actual certification because it's not it's not correcting any underlying problems, right, or adjusting the instrument for underlying problems, but it is essentially doing the same thing, right? So it's actually very common for people to run that profiler on a monthly basis. You know, if you yourself, your shop is ISO certified or whatever, right? Using that profiler on a monthly basis and maintaining those certificates is used by people to meet their own ISO requirements of proving that their measurement equipment is being maintained properly and measuring properly and so forth. The distinction comes in that, again, let's assume that my instrument, the sphere inside my instrument is getting dirtier and dirtier and dirtier. That profiler will keep correcting that, right? But it's correcting or adjusting the fact that the sphere itself is starting to go out and cause the device natively to measure incorrectly. We can keep correcting those errors to a certain degree. There are times when if a device is bad enough, NetProfiler would actually fail. But let's assume it keeps doing that. But then when you send your device in for annual certification, you know, when we certify an instrument, we also clean it. And so, you know, it may not pass, and if it doesn't, there may be some adjustments needed, or like I said, if it's possible that some component requires repair or replacement, that can be done as well to make sure the instrument is back to measuring as good as it possibly can. One of the things to remember with Net Profiler is going to correct the instrument for whatever state it was in at the time you ran your Net Profiler. So worst case scenario, you have a device that's drifting drastically, and you correct it with Net Profiler, but a day or two later, it's drifted again for further away. So, you know, that's an extreme case, but I use it as an example to help understand the difference going on with Net Profiler and certification. The best way to maintain an instrument is using both, of course. Let Net Profiler account for any of those minor drifts that are happening over time, because if you only did annual certification, then you're only going to know 12 months later if your instrument is still measuring right. Well, if something happened in that 12-month period between certification 1 and certification 2, you will have missed something that happened, caused your instrument to start reading differently somewhere in the middle. And how do you go back now and deal with that?
Awesome. Let's see. We got a question here about maintenance. What does the dust filter kit include? We use cans of air and long Q-tips. Is there something else that would help with maintaining my device?
So yeah, the canned air and the Q-tips are things that are identified in the specifically in the cleaning instructions for a variety of instruments. As they do as well, by the way, tell you how to clean the calibration media. Obviously, if you calibrate on a dirty cal plaque, that misaligns things as well. So keeping all of that clean is really important. The dust filter kit literally is this set of it uses Velcro and some stick-on pieces to essentially wrap the entire benchtop device with this 5-micron filter material. It's used in some extremely dusty environments. I mean, these were people who are like literally having to clean their device, you know, multiple times in a day because things are getting dirty that fast. Now, even with the dust filter kit, let's be honest, the instrument still has an opening, right? It's where the measurement takes place. So that opening can allow dust to get in as well. But the dust filter kit is for those extreme environments, and it includes everything you need in order to completely protect the interior components. Because inside you've got lenses and detectors and light sources and all those kinds of things, and it's protecting all of those from this dust adhering to them, which is really the culprit.
Okay, I'll take 2 more questions and then I think we'll be out of time. Are there recommendations for cleaning Net Profiler tiles?
Yes, there are, and there is guidance about that in the tiles themselves. But I can tell you right off the top of my head that the way that we clean them, you need a soft, lint-free cloth, and you typically want to use water or isopropyl alcohol, and that's it. Nothing more stringent than that. And with Net Profiler tiles, as with your calibration tile, same kind of cleaning is done for calibration tiles. You want to clean them, and then you need to let them air dry for a good amount of time, like 30 minutes, because it might look like that water or isopropyl alcohol evaporated very quickly, but it still leaves a bit of residue. I will caution you: do not use, sometimes the disposable glass cleaner wipes that they have. You do not want to use that. You do not want to use glass cleaners of any kind, because some of them have optical brighteners in them, and you can actually cause tiles to change color. So water or isopropyl alcohol and a nice soft, clean, lint-free cloth.
Okay, one more question here. If we have multiple devices in multiple locations, Is a net profiler subscription needed per device? Meaning, would we have a different tile set per device, or would we use the same tile set to profile all our devices?
So technically it could be done either way, but if they're in different locations, of course, you don't want to have to ship tiles around or move them around because of course they're ceramic and you want to protect them very well, right? So the key is this, right? That you could use a different tile set with every single device because all those tile sets have one thing in common. They were measured with an X-rate centroid device, likely the exact same X-rate centroid device, right? And so the values for the tiles, while their tiles are different and their values are going to be different, they were all measured with the same device. So then when you send those tile sets out to, let's say you have 10 different locations, you send them out to those 10 locations, those 10 instruments measure those tiles. What's going to happen is those instruments are each going to be profiled to match back to that same centroid device that measured all those different tile sets. So it ties them all immediately back to each other.
Awesome. There are a lot of great questions here, but that was the last question we have time for. So this will mark the end of our webinar. If we didn't get to your question, we can do our best to follow up with you. I can get these to Tim and we can try to get you some responses here. But again, thanks everyone for joining today, and we will end here. And yeah, have a great day and see you on our next webinar. Thank you.
Thank you.